Hey, welcome back. I'm now going to start reviewing log equations, and after each kind of subsection, wherever it says hit pause, I'm actually going to start a new video, so that will feel a little bit different to you, just so that they don't get long and you can get to the parts that you need to easily. So here we go. I'm going to first start with that terminology, evaluating a log. When we first learned and we were defining logs, we said that a log was the inverse of an exponential, and we could always write a log as an exponential. And we could write it as, oops, can't find my little stick. Here we go. We can always write this particular example as 13 raised to the exponent of y equals 169. Now, I know that 13 squared is 169, so if I rewrite this as 13 raised to the exponent of y equals 13 squared, then based on my exponential information, I know that y has to equal 2. Okay, that easy. In example number 2, I do the same thing. Base 32 raised to the exponent of y has to equal 2. I could have said 2 has to equal base 32 raised to the y, and sometimes it's better to write it that way. Doesn't matter in this one. So I'm going to take 32 and I'm going to write it as 2 to the 5th times the exponent of y equals 2 to the 1st. Okay? That means now my bases are identical, so that means 5y has to equal 1, and so y has to equal 1/5. Now later on in the chapter, we connected some dots with the common log, and we had a formula called the change of base formula. And basically what it said was that you could convert any non-common log and evaluate it by rewriting it as, in this case, for this first one, y equals log base 10 of the number 169 divided by log base 10 of the base 13. So that base becomes that lower of the number. And when we do that and you plug that into your calculator, and remember this is log divided by log. It's not like log of 169 divided by 13. You have to be careful of that. You should get 2. And these two things match. That's a good thing, right? In this case, we could say that the value of that log y has to equal the log base 10 of the number 2 divided by the log base 10 of the number 32. And when you plug that into your calculator, you should get 0.2, which is the equivalent of 1/5. So you can use either of these two techniques. You have to know this for some things, but in certain cases, this is definitely this change of base, that is a really good tool to know, all right? So let's go back and let's work some more problems. Now notice here that I have a single log on one side, all right, set equal to a non-log, but look at where my variables are. Here it's the of the number. Here it's in the of the number. Here it's in the of the number. But look at this one. This one is over here. This is the answer to an exponent. So what did we just learn we could use with this one? We could use change of base. Okay, let's do the first one. Log base 5 of the number x equals 2. Write it as an exponential. So x has to equal my base, which is 5, raised to the second power. So x equals 25. And we're done. the of the number has to be 25. In this expression, in this problem for number 2, notice that I'm in ln. Remember that ln is the same as log base e. So what base am I in? I just said it. I'm in base e. So again, I'm going to write this as an exponential. My of the number, x plus 2, has to be greater than my base, which is what? E raised to the 4th power. And then I'm going to subtract 2 from both sides. Nope, that's an E. Minus 2, and I get x is greater than 52.5982. 5th and 7th hours, I want you guys writing in interval notation, so that's going to be 52.5982 to infinity. Okay, that looks really bad. Let me see if I can erase that, fix that. Okay, all right. Notice, let's do number 4. Okay, notice that I have an inequality and a less than. Whenever you see that, you're going to have to think lower limit. I'm going to write LL for lower limit. Okay, we know that whatever our answer has to be, this of the number cannot go negative. It has to be bigger than 0. So we know for sure that x plus 2 has to be bigger than 0. So that means x has to be greater than negative 2. Regardless of the other answers we get, we know this has to be true. So now we're going to rewrite this as an exponential. And it says my of the number, x plus 2, has to be greater than or equal to my base, which is 3, raised to the 4th power. I'm going to subtract 2 from both sides, which says, oops, this is less than. Kind of did a switcheroo on you there, sorry. So x has to be less than or equal to 3 to the 4th power minus 2. And that says x has to be less than or equal to 79. At the same time, x cannot go under negative 2, so it has to be greater than, x is greater than negative 2. And in interval notation, this is going to be negative 2, 79, and then a bracket. Now, number 3 here, this is just change of base, so let's just use it. X equals log base 10 of the number 12 divided by log base 10 of the number 4, and we get 1.7925. All right, I'm going to have you try number 2, number 5, and number 14. Don't forget these basic log properties. They're super important to remember.